Hello everyone and welcome back to LangGraph Mastery Series. In the previous video, we built our first LangGraph workflow. Our graph looked something like start, agent, and end. The agent could answer questions, but it could not actually do anything. Today, we are going to fix that. We are building a ReAct agent. Now, ReAct stands for Reason, Act, and Observe. So instead of immediately generating an answer, the agent can think about the problem, use a tool, observe the result, think again, and then produce a final answer. Now, let's see how that works. Let's begin with a couple of imports. So here, the first few imports are standard Python utilities. We are importing type, dict, and annotated because we will use them to define our state. Next, we are using the state graph start and end from LangGraph. State graph is the graph we'll build. Start is the execution point and is where execution finishes. We're also importing ToolNode, which is built in LangGraph component responsible for executing tools. Then we import chat OpenAI, which is our language model, and human message represents user input. And finally, the tool decorator, which allows us to convert normal Python functions into tools that the model can use. And next, we're just loading our environment variables over here. And then we have this search tool. So basically, we are working with two tools over here. So here is our first tool. Now, this is a search tool. Notice add tool decorator over here. So that converts a normal Python function into a LangChain tool, okay? Or the LangGraph tool. Once a function becomes a tool, the language model can decide when to use it. For simplicity, we're just returning a mock search results instead of calling a real search API. So in the production system, that could connect to another search provider, of course, right? And the second tool is our calculator tool. If the user asks a mathematical question, the model can choose this tool. And this tool receives an expression and it returns the result. So the try and accept block helps us to safely handle invalid expressions. And then we have a tool list over here. So the list represents all the tools available to the agent. Think of this as the agent's toolbox. At the moment, our agent has to access two tool capabilities. First one is searching information and then performing calculations. Now, every LangGraph revolves around state. So state is a shared memory. Every node can read or write to it. Our state currently contains a single field called messages. This stores the user messages, the AI responses, the tool requests, and the tool outputs. And then this add messages reducer ensures new messages are appended instead of replacing the previous ones. Next, we have the LLM. A lower temperature, of course, gives us more deterministic behavior, which is useful when building agents. Now look at this line carefully. This one is extremely important because we are telling the language model that these tools exist and we are allowed to use them. Without this line, GPT would not know that search, web, and calculator are available. So after binding tools, the model can choose whether it wants to answer directly or call a tool. Next we have is our agent node. Now this is brain of our application. The agent receives the current state. Specifically, it receives the conversation history stored inside messages. We send those messages to the language model using invoke. The model then decides what to do next. It may generate a final answer or it may request a tool. Finally, we return the model response back into state. Okay. Up next, we have this router. We need a decision maker. So that function acts like a traffic controller. So that is what we are doing over here. We are inspecting the most recent message generated by the model. If the model requested a tool call, we return tools. If no tool is needed, we return end. And this determines where execution should go next. And of course, we'll end up creating our graph itself. The graph knows that agent state will be used as shared memory throughout the execution, and then we'll just add the node. Our graph contains two nodes at this point. The agent node handles the reasoning, and the tool node execute tools. Think of the agent as the brain and tool node as the worker that performs action. And execution always begins at start. The first node that runs is the agent. And then we have over here is this is where the graph becomes intelligent. After the agent runs, the router decides what happens next. If a tool is needed, go with the tool node, otherwise finish the execution. Okay, and we'll have the ReAct loop over here at this line. So this is the most important line in the entire program. This creates a ReAct loop. After a tool executes, control returns back to the agent. The agent observes the tool result, then decides whether another action is needed. Without this line, the workflow would stop after using a tool. So with this line only, we are seeing the entire functionality, right? And next, we'll just compile it and run the agent. Finally, it's the time to test the graph over here. So we are asking two questions while we are testing the graph. The first should trigger the search tool, and the second should trigger the calculator tool. For each question, we create a human message and pass it into the graph, and the graph then executes. The agent will reason and use the tool if necessary. And eventually, we'll see the final answer. Once I run this, we'll see the question where it has called the search tool. And for the calculation, we have the calculator tool, right? So here, that's what we have built. Here is a ReAct agent. The agent reasons, the tool node performs action, the router decides where execution should go, and the loop between the tool node and agent creates the reason, act, observe cycle that powers modern AI agents.